Alright guys, today we'll look at ratio and root test. It is 9.6 in the textbook. Alright, let's get started. So, again, we're testing for convergence for series, but specifically the ratio and root test for absolute convergence, which means that the absolute value of the series will converge. So, for the ratio test, we're looking at a sum of a sub n. Um, so when the limit as n approaches infinity of a sub n plus 1, so you're substituting in n plus 1 for n over a sub n, the absolute value of this. When it's less than 1, it converges absolutely. When it equals infinity, or it's greater than 1, it diverges. And when it equals 1, then it's inconclusive and you have to try a different test. Alright, let's try this ratio test out on an example. Let's look at, here we go. Let's look at, I'm looking for a factorial problem. Here we go. Okay. 9 to the n over n minus 2 factorial. Alright, and this is the sum from n equals 1 to infinity. So to do the ratio test, we take the limit as n approaches infinity of 9n plus 1 over n minus 2 plus 1 factorial, and then you do the reciprocal of just 9 or n minus 2 factorial over 9 to the n. Alright, and now let's try to simplify this to see if we can get it into something we can work with. So this will cancel out, so we're left with 9 on top, and let's see, so this is n minus 1 times n minus 2 factorial, and then n minus 2 factorial on top. So these cancel out, so it's 9 over n minus 1, and since this will equal 0, we know that the series converges. Alright, now let's take a look at the root test. So the root test, it's you can't apply it to as many series as the ratio test, but it is quite simple and quite similar to the ratio test. We're looking at the limit n approaches infinity of a series, which the term would be a sub n. We take the nth root of this a sub n absolute value, and when same thing as a ratio test. When it's less than 1, it converges. When it's greater than 1, which also includes infinity, it diverges, and when it equals 1, it's inconclusive. So let's take a look at an example. How about we do alright, let's do this. The series as n equals 1 and it goes to infinity of 6 to the n over n plus 1 to the n. So we take the limit as n approaches infinity of the nth root of 6 to the n, or n plus 1 to the n, and we don't really have to worry about whether this is absolute value or not, because it's going to be positive, as you can see. So this equals the limit as n approaches infinity of 6 over n plus 1. And so this equals 0. So this converges.